Hello everyone. In this video I'll be going over sections review 3 and review 4. So in review 3 we're going to be talking about operations with decimals and percents. So percents come up a lot in our daily lives. You might see a sale 15% off, or you owe this much percent interest on some loan. You know, it comes up in lots of practical ways. So good to familiarize yourself with the concept of percent, and also just a bit about how we represent numbers in decimal also. So we have the hundreds place, we have a tens place. So our system is ordered, right? So we have this hundreds, tens, this is factors of 10 difference, right? So this is 10 to the 0th. 10 to the first, 10 squared. Here's the decimal point, here's 10 to the -1, 10 to the -2, and so on. So we have these different names: 10,000ths place, 10,000ths place, thousandths place, hundredths place, and so on. So this 3 means a lot more than this 4, right? Even though 4 is greater, because 4 is in a lower place value, this 3, if this were money or something, would contribute a lot more of the total than this 4, even though 4 is greater. And similarly, the 5, it's in the ones place. So it's, even though it's 2 greater, in actuality, the 3 and the 5, this 3 is sitting in the hundredths place, so it has a hundreds place, so it has a much different effect than this 5 sitting in the ones place. What is the scale? So the scale is always the smallest visible measurement. So we have a half here, and then they've cut this into what would be a quarter. So the scale would be a quarter. You could also say that if you type this into your calculator, and something I'm going to do is encourage you really to use the heck out of your calculator. If I type 1/4, and then I press this button S to D right here, it tells me 0.25. So either way, this is the fraction, this is the decimal. But yeah, scale is the smallest measurement that you can be absolutely sure about. Graph the number 1.4, so now I'm not going to be totally sure about that. So here's 1.25, so 1.4 is going to be somewhere right about there. Graph -2.25. Here I should be able to locate this exactly. So here's -2.25. So this is C. -0.4, I'm not going to be able to find this one exactly, but it's right about there. E. So 1.9, way over here. All right, round each decimal to the given place value. So you're going to see this coming up in the homework a lot, is you're going to do some calculation, and then often it's going to want you to round to some number of decimal places. The tenths place is another way of saying 1 decimal place. Okay, so this is the tenths place. So that means we're going to have a number that is like 1 decimal long when we're done. So what we do is we look to the digit directly after the place value we care about. If this value is 5 or greater, then we round up. Okay, so in this case, we have a 1.77. So that 7 is, and I'm looking at the 7 I circled, that 7 is 5 or greater. So that means I'm going to round this 7, this next 7, up to an 8. So 1.8. And if you think about it, like if, you know, there was some display on a scale, and this is just the number of digits that you can display on that, or display on that display, then you would need to give the reader of that display the best representation of what you know, right? And this number, if you can only display up to 1 decimal, this number is closer to this number than like 1.7. If you think 1.7, well, check this number out. It's way closer to 1.8 than 1.7, and that's why we have this system. If 4 or less, then down. Then we round down. Let's see if we can find an occurrence of that. So to the thousandths place. So the thousandths place, so this is the tenths place, hundredths, thousandths. So this 2 is in the thousandths place. So this is the number that we're going to be kind of extending this decimal to. We then look at the 0. So this falls into the 4 or less. So this means I would round to 12.452. Right? If I could only display that number of decimals, then this number is more accurate than like 451 or something like that, right? So I'll leave these to you. Going on to page 11, simplify these expressions. This is more order of operation stuff, so GEMDAS, PEMDAS. For sure with the decimals, I'm going to strongly encourage the calculator, so 3.2 plus 4.1 times 2.5. Just hit equals. It's giving us 269 twentieths, so that would be totally fine. Or, let's see what it says. So I pressed S to D again. That would be the decimal representation of it, 13.45. So either way. Okay, I'll leave this next one for you. Now getting into percent. So write as a decimal. So we're converting back and forth between percent and decimal. So 1%, or some number of percent. Percent literally means per 100. So you've heard of a century, right? That prefix cent. So century, a centimeter. All these things mean 100. So this literally means 1 out of 100. So if you go around and ask people what their birthday is or something, maybe 1 out of 100 would have the same birthday as you. Right? So if you ask 100, maybe that would be 1% of people. If you go around and ask 100 people, do they have a favorite color? Maybe 80% of people will say, yeah, I do have a favorite color. Maybe 99% of people will say, yeah. So that would be 99 out of 100 people have a favorite color. So write this this percent as a decimal. Let me ask this. So if 1% is 1/100th, what is 100%? So what does 100% equal as a number, right? This is the number that we get for 1%, 1 out of 100. This is the number 100th. For 100%, we would have 100 out of 100, and that would be the number 1. So the number 1 is actually representative of 100%. So the decimal 1.0 is actually the same as 100%. Okay, so knowing that I think might help. So 8.25%. What I recommend is use your calculator. So 8.25, and then notice there's a percent back here. So shift left parentheses, hit equals. It says 33 over 400. So this is for A. So that would be the fraction. I'll go ahead and press S to D to get the decimal. So 0.0825, that probably makes some sense. Okay. A way of doing that by hand, so if you have 8.25%, that means that you have 8.25 per 100. Sorry about that. Okay, so 8.25 per 100 is the same as moving this decimal to the left twice, right, based on these two zeros. So that would be another way of getting this number. Let's see, write as a percent. Maybe I'll do C and leave B and D for you. So write as a percent, so 0.22. So if 1.0 was 100%, then 0.22 would be 22%. So basically, when we're converting from percent to decimal, we divide by 100. When we convert from decimal to percent, we multiply by 100. So it would have been similar to go 0.22 and then just multiply by 100. So from going to decimal to percent, we can multiply by 100. Going from percent to decimal, we divide by 100. Oops, missed my other two. So that would be the same thing. So I'll do part A here. So this says find 8% of 95. So of is multiply. So I'm going to say 8% multiplied by 95. Calculator, so 8, shift, left parentheses, so I get that percent to pop up, times 95, press S to D. This is 7.6. So 7.6 is 8% of 95. That makes sense. If you don't have that percent, your calculator probably does somewhere, but you could just take 8 divided by 100, because that's what the percent is doing anyways, and then times 95. And then press wave the equal sign maybe on your calculator, but it's S to D on this one. So on to review 4. Yeah, we have this number system. We've talked a bit about the rational numbers, the integers, the whole numbers. So yeah, we have these sets basically. So just to remind ourselves, the real number system, the rational numbers, and then we have the irrational numbers. So the most general set is actually the real number system. And within the real number system, there's a bunch of these different categories of number. So the real number system consists of all the rational and irrational numbers. So you can see the real number system is composed of all the rationals and the irrationals. So what does it mean to be rational? So these rationals are all the integers, the finite decimals, and the repeating decimals. So like 10 is a rational number, 1/3 is a rational number, 117/11 is a rational number. Pi is not. That special number pi is not a rational number. Root 2 is not rational. So those types of numbers, root 2, pi, Euler's number, root 3, cube root of 9, stuff like this, still real, but you cannot find a ratio of numbers to represent pi, so it's not rational. These two systems together represent the real numbers. So classifying, let's see if we can talk about which one it is. So is 8.3 a whole number? Keep in mind the whole numbers or 0, 1, 2, 3, 4, and so on. Right, so is 8.3 one of those numbers? No. So I'm just not going to put a check mark here. Is it an integer? What were the integers? So these were the whole numbers, also called the natural numbers. Sorry, the natural numbers being 1, so let me be clear about that. So these are the counting numbers. The whole numbers just to add in 0. And then the integers I'll write down here. These are the ones that extend into the negative side. So that's why I'm saying 8.3, not a whole number, not an integer either. Rational number. So a rational number, just to be clear about what a rational number is a rational number, you can find a ratio of integers for that value. So if I type in 8.3 and then press equals, this is the rational number. This is the ratio of numbers that 8.3 is equivalent to. So 83 over 10. So that would tell me that yes, it's rational actually. So maybe I'll be clear about this. So that would tell me rational. Another way of determining that 8.3 is rational is that its decimal ends, but also there's a pattern, right? So 8.3 is the same as 8.30000000000 forever. And that's actually a pattern. Sometimes we draw a bar over to represent the pattern. So that's another way of saying that that thing is rational, is that it has a pattern in its decimal. If it's rational, it's never irrational. And it is real. You can have $8.3. That's a real thing. Negative 4/3, is it a whole number? No. Is it an integer? No, right? We jump right over it. It's this fraction. Is it a rational number? Yes. Right, it's already a ratio of integers here. If it's rational, it's not going to be irrational. It is real. Right? You can owe someone negative 4/3 dollars, I don't know, or you can owe them 4/3 dollars, if you want to think of it that way. 56, that's a whole number, right? That'll be just way down here. That's an integer also. It's also just way down here. It's a rational number, right? 56 is 56 over 1, right? And that's a ratio of integers. If it's rational, it's not going to be irrational. And it is real. You can have 56 donuts. Pi. So pi, if I type on my calculator, there's a pi way down here. So right there is the symbol pi, so I'll need to press shift and then that button. So that was shift and then this button. Pi is not rational, and even though it looks like its decimal ends, actually it doesn't. This is just the calculator doing the best it can. So no, it's not a whole number, not an integer. It's not even rational, it's irrational, because you cannot find a ratio of numbers that is exactly pi. That is to say, you can't find a ratio of integers that is exactly pi. But it is real. Pi is a circle's circumference divided by its diameter. So that's totally real. What about negative 15? That is not a whole number, right? There's no negatives in the whole numbers. Is it an integer? Yes, right? It's just way down here. Is it rational? Yeah. Negative 15 is negative 15 over 1. If it's rational, it's not irrational, and it is real. All right, on to example 12. I'll just do part 1 here. Convert 0.255 to a fraction in the simplest form. Is this number a rational number or an irrational number? So the way that I would do that is like this 0.255 hit equals on this calculator. There it is. It says 51/200. That is completely rational because it is a ratio of integers. So if you don't have this type of calculator, what I would do is write this down and then figure out how far you need this decimal to move to the right to kind of form an integer. So you would need to multiply this by 10 to the third. So 1,000 top and bottom. So this is what I would do. Sorry, I wrote that kind of weird. But 1,000 top and bottom, that moves this decimal to the right 3 times. So now I just have 255. And then 1 times 1,000, I have 1,000. And 5, I guess, times 51 over 5 times 200. These cancel. And then I have my 51/200. And same reason as here. Okay, looks like that's it for now. All right, be well. I'll talk to you next time.